Now let us look at the standard forms of an hyperbola. So the equation that is used to represent an hyperbola, which is in standard form, that means the center is at the origin 0, 0. The equation is x square by a square minus y square by b square is equals to 1. So this is our standard equation of an hyperbola. And how does this standard hyperbola looks like? It is in this format. So this is our curve of our hyperbola. This is our directrix 1, this is our directrix 2, this is our foci 1, and this is our foci 2. So how do we write now the values in this? Focus is written as AE, 0, the same as we had written in ellipse. Now you can understand that in hyperbola E is greater than 1. That means AE would be a value which is greater than A. In ellipse we had studied that the focus is also AE, but in that case E was less than 1. That means AE would have been less than A. Here it is completely different, and this is directrix 1. So its equation is written as x is equals to plus A by E. This one is D2. Its equation is written as x is equals to minus A by E. This is our center 0, 0. This distance here is A. That means the vertex is written as A, 0. The other vertex is written as minus A, 0. The other focus is written as minus AE, 0. And this is how we represent. This is known as our conjugate axis. This is our transverse axis. This is our conjugate axis. And now from this entire thing you would have understood that since E is greater than 1, that means the formula for calculating E would have also been changed. Now earlier when studying ellipse you have looked that E square is equals to 1 minus B square by A square. That was the formula that we had studied. However, now E square becomes 1 plus B square by A square. This is how E is calculated, eccentricity, where again A is greater than B, and this is how we represent our eccentricity. And one more thing here, that if you remember, C square was also a term that we had studied in ellipse, which used to be A square minus B square. However, now it would become A square plus B square. So this was a type of an hyperbola. Now let us look at the vertical part of it. This is known as again a horizontal hyperbola. Now let us look at a type of a vertical hyperbola. So now this would become the y-axis here, this would become our transverse axis. And this becomes our conjugate axis. Now you must be asking, for example, let us take in the horizontal hyperbola, what is the value of B? Again, B is nothing but just an imaginary point that we are using just so that we can represent B as AE square minus 1. Basically, we want to represent B square as A square. Sorry for that. So that we can B square can be represented as A square E square plus 1, sorry, minus 1. So we have to minus A square, sorry. So we have to represent this value in by using some variable, and so that variable that we are using is B, 0, B. So this is it in the conjugate axis. So similarly here, the equation of this hyperbola would be written in this format: y square by A square minus x square by B square is equals to 1. Now again, things more or less are same. A is still greater than B here, and E square is still written as 1 plus B square by A square. The only difference here is that now the values would have changed. The vertex would become 0, minus A and 0, A. The center remains same at 0, 0. Our directrix, equation of directrix would just change to y is equals to minus A by E, and this one would become y is equals to a by e, and our foci f2 would be 0 comma minus ae, and this one would be f1 would be 0 comma ae. So nothing different from the horizontal hyperbola. The only thing is that the values have been shifted to the y coordinates and the equations have been transformed to y1, y values, and the equation is written as this format: y square by a square minus x square by b square, which is equals to 1. Basically, we've replaced x with y and y with x. So here the same things have been mentioned. Horizontal transverse axis, when we have our hyperbola in the horizontal transverse axis, then the equation is written in this format. And let's say when we would have vertical transverse axis, so in this line here you can see that the transverse axis is in horizontal format. That is why we call the horizontal hyperbola as horizontal transverse axis. And here the transverse axis has become perpendicular to the earlier one. That means it is a vertical transverse axis which opens up and down. So the equation is written as y square by a square minus x square by b square is equals to 1. Here a is the distance from center to the vertices along the x-axis and b is related to the distance along y-axis. Now b again is imaginary. Now the value of b is real. The reason we are considering the variable b is imaginary. Don't confuse yourself with that. And e is again written by c by a, and as we had looked in the previous slide, c is nothing but root under a square plus b square upon a. Now the length of latus rectum. Let us look at this. Let's say this is our hyperbola given to us. Again, the formula for length of latus rectum remains same for both the hyperbolas, which is 2b square by a. You have to remember this. Let's say this is our focus. This is our latus rectum. So the distance from this point to this point, this length is our 2b square by a. Now again, there are going to be two latus rectums in an hyperbola, one which is in the positive x side and one which is in the negative x side. Now let us look at all the standard values just so that you remember all these things. Horizontal hyperbola is written as x square by a square minus y square by b square is equals to 1, and vertical is written as y square by a square minus x square by b square equals to 1. Center is the same at 0 comma 0 for standard form. For h comma k, the equation would be just a little bit different as we had studied in ellipse, which would become x minus h whole square by a square minus y minus k whole square by b square. We will look into that as well in the later slides. The vertices becomes plus minus a comma 0 0 comma plus minus a. Length of transverse axis, conjugate axis, eccentricity, length of latus rectum, all these things are same. Equation of directrix for horizontal would become plus minus a by e, and here this would become plus minus a by e. It is same. The only thing is that the coordinates and the axis we are changing from both the hyperbolas. X becomes y and y becomes x. Now let us look at a question to get more used to the concepts and eccentricity values of hyperbola. So in this question, E1 and E2 are the eccentricities of the ellipse x square by 18 plus y square by 4 is equals to 1, and the hyperbola this respectively. And E1 E2 is a point on the ellipse, then the value of k is equal to. Now this was a question that was asked in JEE mains previously. Let us solve this question. Again, a very easy question, not very much concepts or very much detail or brains that you have to use here. Ellipse has been given to us. X square by 18 plus y square by 4 is equals to 1. Here we have to find out the eccentricity, which would be E1. So let us find it out. E square we know for an ellipse is 1 minus b square by a square. So this would become 1 minus b square is 4 by a square 18 e square. So e square would be equal to 18 minus 4, which makes it 14 by 18. 2 7s are 2 9s are. So E1 comes out to be root 7 by 3. We've got the value of E1. Now let us find out the value of E2. For E2, we have been provided a hyperbola. Now again, by looking at the equation, if they had not mentioned that this is an ellipse or this is an hyperbola, just by looking at their equation, you can make out that this is an ellipse because all the terms of x square and y square are positive. And in hyperbola, at least one of the terms or the coefficient would be negative. Y square by 4 is equals to 1. So the value we have to find out of E2. And in hyperbola, E square is written as 1 plus b square by a square. So this would be 1 plus 4 by 9, which makes it 13 by 9, so E square. So E2 is nothing but root 13 by 3. Now what has been told to us? There is a point E1 comma E2. So E1 comma E2 becomes root 7, this is root 7 by 3 comma root 13 by 3. This is our E1 comma E2. Now we have to see that this is a point on the ellipse. That means if this point is existing on the ellipse, that means if we put the values of E1 E2 in this ellipse, it would satisfy this condition. And through that we can find out the value of k. That means 15x square plus 3y square is equals to k. This point lies on this ellipse. That means 15 E1 square plus 3 E2 square would be equal to k. This equation would be satisfied. And from here we can get the value of k. So let us solve this. This would become 15 into 7 by 9 plus 3 into 13 by 9. So this would ultimately be equal to 3 5s are 15, 3 3s are 9, 3 1s are 3 3s are 9. And after taking LCM to be 3, we get 7 5s are 35 plus 13, which would make it 48. So 3 1s are and 3 6s are. That means is equal to k. That means k, the value of k that we found out is 16. This is our answer. And this was one of the questions that was asked in JEE Mains. So you can see the level of questions that are asked in JEE Mains. They are very simple, very easy, can be solved. Let's look at another question. 5x plus 9 is equal to 0 is the directrix of the hyperbola. 16x square minus 9y square is equal to 144. Then its corresponding focus is. So first let us write down the equation of this hyperbola in its standard format, where we have to make 1 on the right hand side. So this would become x square. After taking 144 below, we would get x square by 9 minus y square by 16 is equals to 1. This is our hyperbola standard. This is y. And the directrix that has been provided to us is 5x plus 9 is equals to 0. So this can be written as x is equals to minus 9 by 5. And we know for an hyperbola, the directrix is written as x is equals to plus minus a by e. So here the minus sign is here. That means 9 by 5 can be equal to a by e. So we can say this thing. Again, since x is equal to minus 9 by 5, that means the directrix is lying on the negative x-axis. So that is why we have taken, from here also we have taken x to be minus a by e and equated those two. So the minus sign has been cancelled and a by e is equal to 9 by 5. From this equation of hyperbola, we can see that a is equal to 3, nothing but 3. So now let's put a in this equation. We would get 9 by 5 is equals to 3 by e. So e is equal to 5 by 3. This is the value of eccentricity that we have gotten. Now they have asked us what is the corresponding focus. So the focus is of standard hyperbola is written as plus minus ae comma 0 for f1 and 2. So what would our focus become? f1 would become a into e, which would become 5 comma 0, and f2 would become minus 5 comma 0. So this is our answer. Now in this question there was a catch that was given. This was our answer, that the question is complete. Again, this was a question that was asked in JEE Mains. Sometimes what happens is, by looking at the equation of this hyperbola, students might get confused. The reason being, in this equation, if you look at it carefully, a is less than b. Here a is equal to 3 and b is equal to 4. So sometimes you might get confused that since a is not greater than b, that means the equation would change or the standard terminologies would change. Absolutely not. Even if a is less than b, the entire procedure of solving and finding out the different terminologies of hyperbola would remain same. So you had to keep that in mind. Again, a question asked in JEE means, very simple, nothing much difficulty in solving such questions.